welcome form. All right, so I'm going to use this method once and only once because I'm going to show you a better way that has more applications. So this is going to be writing equation of a line given slope and a point, and we're going to be solving for the y-intercept. So we're going to use slope-intercept form. So we're going to substitute the slope m and the coordinates of the given point x, y into the slope-intercept form, y equals mx plus b, and we're going to solve for b. So this is the one and only time I ever do this because it's something you know, and then I'm going to show you another way. Right, and then we're going to write the equation of the line. We'll substitute the slope m and the y-intercept b into the slope form, y equals mx plus b, after we've solved for it. And the relationship will hold for any pair of points. That's why we can use any point to solve for the y-intercept. All right, so we're going to write the equation of a line that passes through the point 6, -3 and has a slope of -4. All right, so there's the y-intercept, the slope-intercept form of our line. We know what m is, right? So m here is -4. And here's an x and a y. It's not the y-intercept, but it's a y. Right? And so we know that we have a y-coordinates that's -3. We have a slope of -4. And when y is -3, x is 6. Right? So every pair of points on this line has the exact same relationship. That's why any point can be used to solve for the y-intercept. So we have -3 equals -24 plus b. And now we'd add 24 to both sides. So that's going to give us 21 equals b. Now that I have the y-intercept, I have to substitute the slope, which was -4, and 21 for the y-intercept. So we have y equals -4x plus 21. Let's look at another way of solving for the y-intercept. In other words, another way of writing our equation in slope-intercept form. And this other way is called point slope. It's very important to learn point slope. Not only is it a way to find your y-intercept, but it's also a type of equation for the line itself. Right? So slope-intercept is one type of format for writing the equation of a line. Something called standard form is another format we can write the equation of the line. And a third format is point slope form. So point slope form is an equation of the line. And sometimes when you're asked to write the equation of a line, you can just use point slope form, which is really easy. But if you're asked for slope-intercept form, if you simplify point slope form, you automatically get slope-intercept form. All right, so another format for a straight line equations is called the point slope form, where x1, y1 is a point on the line. So just like before, we're substituting a point on the line. Here, when we substituted the point on the line, right, we found a number. Right? That just gave us the y-intercept. We had to put the y and the x back into the equation, right? Because there are many, many points on this line, not just one point. Right? And so there are an infinite number of x, y combinations. So that's why we have to have those variables back. In point slope form, we leave the variables in. They're the ones without the subscripts. So x and y without a subscript, those are variables. x1 and y1, that's a point. And it can be any point on the line. And then m is the slope. When we substitute for the x1 and y1 in the equation and the slope, we have the point slope form. And if that's all we're asked to do, we can leave it like that. But we can also simplify it and put it in slope-intercept form. So you have the generic x and the generic y. Those are variables. That's right, variables that are always present in your equation. And then you have the specific x and y from the point they gave you. You only need to know a point and the slope to write an equation in point slope form. Substitute the slope m and the coordinates of the given point x, y into the point slope form. That's our first step. And then we're going to simplify that into the form y equals mx plus b. In other words, we're going to isolate y. So we're going to write an equation of a line that passes through the point 6, negative 3 and has a slope of negative 4. So we leave the y. We replace the y1 with negative 3. Notice there's a negative already in the equation. That's always true. This is our format. The subtraction signs are already there. So I don't have minus 3, I have minus and negative 3. Equals, our slope was negative 4. The x is a variable, and we replace the x1 with a 6. This right here is point slope form. In algebra 2, we sometimes stop right here, except we would simplify those double negatives. So we would make this 1 plus 3 equals negative 4 times x minus 6. Technically, this one would be the point slope form, because we wouldn't leave a double negative in there. That looks weird. Right? That would be point slope form. And so next year in your algebra 2, this is sometimes where we stop. And sometimes we continue simplifying it. When you're in calculus, we almost always leave it like this. Or we might just move the 3 and isolate the y. Right? So as you go on, you'll find you're using point slope more and more and slope intercept less and less. But on the benchmark, on the formatives, your answers are going to be in slope intercept form. It's important to be able to use slope intercept form. So for us in this class, we'll almost always simplify it to slope intercept form. All right? Not always, but almost always. Let's say like 75% of the time. So y plus 3 is equal to, we just have to distribute the negative 4 to simplify this to slope intercept form, because we're trying to get the y by itself. So we have negative 4x, negative 4 times a negative 6 is a positive 24, and then we subtract 3 from both sides. All right, just subtract 3. So y is equal to negative 4x plus 21. Notice we got the same equation as before, because it's the same line. So negative 4x plus 21, and back here, if I go one more, y equals negative 4x plus 21. But we didn't have to, once we found the y-intercept, we didn't have to write the equation. Once we simplified it, it was in slope-intercept form, and we had the y-intercept. We didn't even have to solve for it. Right? So all you have to do is plug into the point-slope form, and then you're going to just distribute. And to isolate your y, depending if it's positive or negative, you'll add or subtract to move that term, and you isolated y, and you're done. All right, so it's a really easy format to work with, and it's a format you need to master. Let's do some more. All right, so we're going to use point-slope formula to write an equation of a line given slope and a point. Okay, so we just substitute the slope and the coordinates of the point we're given into point-slope form. Y minus y1 equals m times x minus x1, and then we just simplify it into the slope-intercept form. So we distribute, and we isolate y. All right, so this is our x3 is our x1, 5 is our y1, and that's our slope. So we have y minus 5 equals 2/3 x minus 3. We'll distribute. Y minus 5 equals 2/3 x. All right, so if you have trouble multiplying 2/3 times a fraction times a non-fraction, an integer, or a fraction times a fraction, you can just write it over here, right off to the side. So now I look and I see, oh, look at that. So you can cross-reduce when you're multiplying fractions. So if the 3's are going to cancel out, I've got 2 times negative 1, right? Because 3 would go into 3 once, and 3 would go into negative 3. Let's make that negative clear. Negative 1. So you have 2 times negative 1, which is negative 2, and you don't need 1 times 1 in the denominator. So this is going to be a negative 2. And now all we do is add 5 to both sides. So y is equal to 2/3 x plus 3. And there we're done. Right? So our y-intercept is 3, the 0.03. Our slope, of course, we were given, so that was pretty easy to figure out. It's 2/3. Let's do another one. I think I have another one. All right, so I have another one, but this time you're not going to be given the slope. But that's okay. I'm going to give you 2 points, and you can just use a slope formula to find the slope. All right, so using the point-slope form with 2 points. You can also use the point-slope form of an equation to write the equation of a line in slope-intercept form when we only know 2 points on the line. Before we can use the point-slope form, we have to find one critical piece of information, the slope. All right, so example here, use the point-slope form of a line to write an equation of the line that passes through the points 6, -2, and 4, 8. All right, so when you're calculating out your slope, it doesn't matter which point is first and which point is second. I'll just go kind of left to right, except that's an x, and a y wrote y. Must be thinking of the next step. In other words, take the difference in the y coordinates, and I wrote it at y for some reason. So x1, y1. All right, so there's my second point, there's my first point. All right, so I'm going to have -2 minus 8 divided by 6 minus 4. We'll simplify. -2 minus 8, that's -10. 6 minus 4 is 2. That's going to reduce to -5. There's our slope. So we're going to use the slope and either point as x1, y1 in the point slope form. Let's use 6, 2. So it was labeled with 2's, it doesn't matter. All right, so this is the one we're going to substitute for the x1, y1 in our equation here. All right, and we have our slope. Of course, our slope is -5. All right, so I'll squeeze this one. I don't have your notes in front of me, so just make sure you're following along and looking to see if this is one of the problems I did. All right, so we have y. So now I've got a minus and -2 is equal to -5, and that would be x minus 6. Let's simplify that double negative. Y plus 2 equals, and there's no reason why we couldn't now just distribute in the same step. So -5 times x is -5x. -5 times -6 is a positive 30. Our last step is to subtract 2 from both sides. So we have y is equal to -5x plus 28. There we go. All right, and we can tell from our equation now that our y-intercept is equal to 0.028. We'll just do a few practices with that, just to make sure you know which number there is the y-intercept. All right, so we use in this problem here, we chose 6, -2. What if we had chosen the other point, 4, 8? Well, let's find out what happens. All right, so remember the format is y minus y1 equals m times x minus x1. All right, and so now the point was 4, 8. Right? I believe they were both positive numbers, but I'll just double check. Yes. All right, and remember our slope, that was -5. So we have y minus 8 equals -5 times x minus 4. No double negative to simplify, so let's just distribute. Y minus 8 equals -5 times x is -5x. -5 times -4 is a positive 20. And now to isolate y, we just add 8 to both sides. So y is equal to -5x plus 28. And there we're done. And notice we got the very same equation. So you can use either point in point slope form. It makes absolutely no difference which point you use, because the relationship between every x value and its corresponding y value is the same. So pick whichever one you like. Maybe we'll choose the one with the smaller numbers. All right, so we're going to write an equation of a line given 2 points. All right, so and we're going to write an equation of a line that passes through the points 1, 4, and 3, 2. So our first step, always when we have 2 points, is to find the slope. And just so that you remember, it's the difference in the y coordinates, or the change in y, over the difference in the x coordinates, or the change in x. Why did I write an x? Or y? When I'm saying x, or the change in x. I must be tired. All right, so it doesn't matter who's first and who's second. All right, so you be x and you be y. I think it's because I write y's first when I'm writing the slope formula. I just want to write a y first. And this is you be the first point. All right, so this would be 4 minus 2 divided by, and that would be 1 minus 3. So it doesn't matter which point is first and which is second, just be consistent. So notice 4, 1, or actually if I look the other way, 1, 4 is a point and 3, 2 is a point, right? So they're matched up. All right, we'll simplify. This would be 2 and negative 2, which is just negative 1. All right, so that's our slope. And we have to pick a point. It doesn't matter which one. 1, 4, 3, 2. I'd ask you, but I can't hear you. So I'll just pick the first point this time. So 1, 4, you're going to go in. All right, so we're going to substitute the 4, where we have y1. And then we have negative 1, and we'll have x minus 1. All right, so I just decided to use the first point. Maybe next time I'll use the second point. So we have y minus 4 equals negative 1 times x is a negative x. Negative 1 times negative 1 is a positive 1. And now all I have to do is add. All I have to do is add 4 to both sides to isolate y. So we have y is equal to negative x plus 5. And there we go. We're in slope-intercept form. So just as a little reminder, your y-intercept would be the point 0, 5. And of course our slope we found was negative 1. And if we use the other point, if I use the 3, 2, I'd get the exact same thing. I think this might be the last one. Yes, it is. All right, one more. All right, so our first step, of course, is to find the slope. So we're writing the equation of a line that passes through the points 8, 3 and 6, 2. All right, so we'll find the slope of the line. Just as a reminder, that would be the difference in the y coordinates, so y2 minus y1, divided by the difference in the x coordinates, x2 minus x1. By the way, if I wanted to, I could also write, let's put or. I'll put equals, because these things are going to be equivalent. I could also have written y1 minus y2, x1 minus x2, right? Either way, it's fine. Right? The only reason that we just tend to, make 1.2 and 1.1, and since 2 is greater, we tend to do just y2 minus y1. But there's no reason it couldn't be y1 minus y2. Right? You get the exact same answer. Right? So it doesn't matter which one I use. Since I've already written it y1 minus y2, I'll use that one. Right? So I've got 2 minus 3 divided by 6 minus 8. And so long as I've got 6, 2 as a point, 8, 3 is a point, they're lined up, it's fine. 2 minus 3 is a negative 1, and 6 minus 8 is a negative 2. Of course, if I had done it with 8, 3 first, I wouldn't have any negative numbers, but it doesn't matter because the negatives cancel, and that's just positive 1/2. All right, and so I said I would use the second point this time. All right, so we're going to use the one that is labeled 6, 2. All right, so we have y minus 2 equals, and our slope is 1/2, and x minus 6. All right, so now we just need to distribute. This one I don't think we need to write to the side, because what's half of negative 6? Well, half of negative 6 is negative 3. And then we'll add 2 to both sides. So our equation in slope-intercept form is y equals 1/2 x minus 1, because negative 3 plus 2 would be a negative 1. And just as a reminder, the y-intercept is 0, negative 1. Right? Y is always the second coordinate. And there we go. That's all there is to these. So I have some for you to do. Probably going to come up in a second. There we are. And you're just going to be writing these in point-slope form, and you're going to simplify to slope-intercept form. Make sure I see that point-slope form. And on this one, you'll have to find the slope as well. I don't know why there's a kind of a random blue line here. It has nothing to do with anything. And this will be posted on the website. Thanks for watching. Bye for now.